Okay, we're going to take a look at this space heater that's in my basement, okay? My basement gets a little bit cold, so I decided to put in a 2500 watt space heater here. And now, when it came, it had a little selector switch here, so a little toggle, so I could just click toggle it on and toggle it off, right? On, off. Well, I was a little bit worried about that because I didn't want my kids to leave it running and then we would go upstairs and then 2500 watts is a fair amount and you'd get a huge electric bill. So I took that little toggle out and I put a little dial in here. So when I dial it, it then is going to time, because it's a little timer for a certain amount of time, and then it times out, and then after a while it would click off, okay? So I had to put a little motor controller in here because I took the toggle out and I put this timer in here. And well, let's take a look at the schematics of this and see if it makes sense to you. Let's take a quick analysis of the heater. So basically in that wall, I had my heater right here, okay? And then on that heater, I kind of had some kind of a dial here, which when I dialed it up, it would close a switch right here for a certain amount of time, and then that's what, you know, fed the heater. And this is all kind of an integrated unit here, okay? So that's what I was coming up with. I originally, when I got this, it had like a little toggle switch here. I could just toggle it off and toggle it on, okay? But I wanted to put in the timer so that it didn't run all the time. Okay, so the first thing that we had to take a look at was the wattage of it. So it was 2500 watts. Now we've learned that your current is your power over your voltage. So 2500 watts, if I just wanted to plug it into the wall in 220 volts, well, if I divide that out, I'm going to get 2500 divided by 120. I'm going to get 20.83 amps. Okay. Now that's a problem. And I'll tell you why it's a problem. I use 2500 watts because that was what the heater was rated for, and recognize that that heater's got some resistive elements in it, and it's got some inductive elements in it. And so maybe this isn't 100% right, and you're going to learn about the difference later on in the program. But it's pretty close. You know, I'm just doing a rough guesstimate here, and I'm at 20 amps. And the problem with that is that you can run either 12 or 14 gauge wire in your house typically, and your breaker box and all the switches and everything is set up for that, and that's usually rated for 15 amps or for 20 amps. So this is kind of high amperage to be running residential in your house. There's certainly items in your house that run more than that, but that was a little bit concerning. So what I had to do was I had to do 2500 watts, and I had to go over 250 volts. I had to run it on high voltage, and so because I doubled the voltage, the amps were cut in half at 20.41 amps. Okay, so now I'm looking better. I got to run on high voltage, and I'm going to be drawing 10.4 amps. All right. So the next issue that I had was I went and I got the timer switch, and the timer switches, the little switches, they're not really rated for high voltage in amps. They're rated for, you know, typically 120 volts. And certainly they can't switch 20 amps. That would burn that little timer contacts up. But I can't run 240 volts for it either because it's not rated for that. Okay, it's not rated for the high voltage. So I couldn't just directly hook this timer in here. I needed to use a relay. Okay, I just used a little control relay like this that we've been talking about. And here's the pinout of the control relay. Okay, so it looks like 2 and 7 are the coil, and then I've got a couple of contacts here that switch. It looks like 1 and 3 close, and it looks like 6 and 8 close when the relay's on. Okay, so with the relay, what I did is I needed to turn on the relay. Okay, so when I went to my breaker box, this relay that I used, one of these little control relay, was 120 volt relay. All right, so what I did was I ran the black wire from the circuit box, which is this is on a circuit breaker, by the way. There's a circuit breaker on that, and I ran it through my switch right there, and I put a little dial there, so that switch closes for 5 minutes, 10 minutes, or whatever. Okay, and what I did was I ran that to the control relay, and then it comes back to the box as white because that was my neutral. So when I turned on the switch, what that did is it turned on the control relay. You hear a little click, all right? And the little click that you hear is the control relay. It's not the heater coming on. This turns on the control relay. Now the control relay has got a couple contacts in it there, okay? So I had my contacts for this control relay right here were 2 and 7. That was the coil. And then I had a switch here which was 1 and 3. And the second switch was, looks like 6 and 8. Okay, 6 and 8. So I had 2 that closed. All right. So then what I did was I needed high voltage. Okay, so I had to use the red wire as well. So I took one of the switches, okay, and I switched through the red wire. Okay. And then the other switch, I had to pick off the black back from my box again, okay? So I had to run a black wire, and I ran that to another one to the other switch, okay? So that when that closed, on this side I had black and I had the red, which was 240 volts right there. And what I did is I ran those into the heater, which consisted of a fan, okay, and it consisted of a heating element. So when I, once again, turned on this little switch here, because this wasn't rated for high enough voltage, I turned on a control relay, which was between black and white, which was 120 volts. And that closed these switches between the black and the red of the house, which was 240 volts, and it turned this on. So let's see. I guess it's a little bit of a motor controller. Do I have a disconnect? Well, I don't have like a knife disconnect or spring-loaded contacts or anything like that to disconnect. I just have my breaker box. I have my main. If I turned off the main, I guess all the power would go dead in my house, including this. So I guess maybe I got a disconnect. Do I have short circuit protection? Well, I do have short circuit protection because every one of your circuits in your house is on a resettable circuit breaker. So these ran back to my breaker box, and in there, this was on a circuit breaker. So I did have my short circuit protection, and a start stop. Yep, I had a little switch here that was on a timer, so I had a start stop. And then did I have overload protection? Well, not in the sense that we have for motor controls, but the heater right here does have an internal overload. So if this, for some reason, this heater got too hot, it has an overload in there that would trip and would shut it off, okay? Now, this control relay would stay on if this was closed for the still amount of time. It's just that the heater would stop working until that cooled down. And when it cooled down, it would start right back up because these contacts would be closed as long as that is on. So it didn't have low voltage protection here to drop out the control relay because there was no memory on here. I just had this maintained timer switch. So yeah, I guess it kind of works for a motor controller. But let's look at a different situation where we might have each of those items there.